Section 5.9, Fractional Equations. We are going to take everything we've used this week and apply it today, whether it's multiplying by a common denominator, simplifying fractions, and doing all those things we need to solve these problems. So, here we go. How do we solve and use fractional equations? We probably should figure out what exactly a fractional equation is. Well, they're an equation where a variable occurs in the denominator. Yesterday we dealt with problems with integers in the denominator. Today we deal with variables like x or y. The big thing for today is if you multiply both sides by the least common denominator of the fractions, if there's a variable in it, the resulting equation is not always equivalent to the original. And we'll see what this means beginning with number 3. But first, let's do number 1. So you see the question before you. We first need to figure out what the least common denominator is among the fractions. So we have an x and a 2x, and as you've probably figured out, the least common denominator is 2x. So you have to multiply every expression, every term in the equation by 2x. So I'm going to show you how to write it out. Now you don't always have to do this step. I'm showing you each step just so that all of you can see what it takes, because it's very easy to make a mistake along the way. So we multiply 2x by 1 over x, negative 2x times 1 over 2x, and 2x times 3. We simplify that, you get 2 minus 1 equals 6x, and solve for x. X is 1 over 6. And because we have an equation, you need to state your answer in a solution set. So again, find the least common denominator, multiply every term in the equation by that denominator, and simplify. And solve for x. Number 2, now we have an a and an a plus 1 in the denominator. There are no common factors between a and a plus 1, so hopefully by now you know that the least common denominator of those two expressions is a times a plus 1. Remember, the goal of this is to eliminate all the denominators so you can work with an equation that's easier to solve. So again, I'm going to state the whole thing, and you notice how all three terms are multiplied by the combination a times a plus 1. So the a's cancel in the first term, the a's plus 1's cancel in the second term. If we put that all together, you get a plus 1 plus 4a equals 6a squared plus 6a. Now, because we have a quadratic in the equation, we must put everything equal to 0, and you're going to have to factor. If you factor this, you get 3a minus 1 times 2a plus 1 equals 0. So a is either 1/3 or negative 1/2, and you express that as a solution set. So again, when you have denominators that do not have a common factor, you're probably going to have to multiply every term by this times this and solve for a. An extraneous root is a root of the transformed equation that's not a root of the original equation. So you must check each root with the original equation to make sure that you don't have a root that's excluded from the domain. In other words, when you solve for x or whatever variable, you need to go back, look at your zeros, your roots, check them in the original equation to make sure it doesn't make a denominator 0. If it does, then you need to take that out of the solution set. Let's take a look at number 3. So, go ahead and figure out what we need to multiply both or all three expressions by. You need to find the least common multiple of all the denominators. So, I first flipped the 3 minus z on the bottom by taking out a negative 1, so this becomes a z minus 3. I factored the z squared minus 9 into z plus 3 and z minus 3. Now it's much easier to see what the least common denominators are. It's basically z plus 3 and z minus 3. So we need to multiply every term by this quantity. And again, I'm writing this all out for you to see. It is long, and you don't always have to do this because you'll see some shortcuts. So, first thing we'll see is that z minus 3 cancels in the first term, the z plus 3's and the z minus 3's cancel in the second, and the z plus 3's cancel on the right side. You take all that and you rewrite it, you get that expression. Remember, there's still a negative sign that's hanging out there. And here we have another thing you have to multiply together, which we're going to do now. You're going to have to FOIL this one. And don't forget when you take z plus 3 quantity squared to make it negative. So you get negative z squared minus 6z minus 9 plus 11z plus 3 equals negative 5z squared plus 16z minus 3. Now, because we have a z squared term, we need to combine like terms, set one side equal to 0, and then factor. So if you do all that, you get 4z squared minus 11z minus 3 equals 0. If you factor this, you will see you get 4z plus 1 times z minus 3. I'm presuming that you all can factor this. I'm moving very quickly because I'm not going to spend time showing how to factor. If you still need help factoring, you're going to have to ask me. So this means z is either negative 1/4 or z equals 3. Sounds great, right? Well, remember the extraneous root. We need to check to make sure that these numbers are in the domain. As you can see, putting in z is 3 would make this and this term divided by 0. And so therefore 3 is actually not part of the domain. So it's an extraneous root. So we have to get rid of it, and the only solution is z is negative 1/4. So again, with extraneous roots, when you multiply out by variables, you need to make sure that all your roots fit in the original equation and don't cause the denominator to equal 0. Number 4, you see the expression there. Go ahead and try this on your own. Don't forget when you solve for x to go back and check to make sure that the x's are not extraneous roots. So if you factor the expression on the left, you get an x plus 2 and an x minus 2 in the denominator. This also happens to be the least common multiple. So let's multiply every term by this quantity, and you get this. So on the left side, the first term cancels out nicely. The x plus 2's are gone, the x minus 2's are gone, unsurprisingly. On the right, you have the x plus 2's gone in the last term. If you combine all that, you get 10 equals x squared minus 4 minus x plus 2. Alright, so now let's all combine like terms. You get x squared minus x minus 12. We factor that to get x minus 4 times x plus 3 is 0. And so x is equal to 4 or negative 3. If you look at the original equation, neither 4 nor negative 3 would cause the denominator to be 0, so our answer is negative 3 and 4. Finally, we have example 5. You have 3 terms, 2 on the left, 1 on the right. Don't forget, the first thing you have to do is factor the denominator here so you know what the common factors are. So we do that, and you get x plus 1 times x minus 1. Now go ahead and multiply out by the least common multiple and see what you get for x. Again, checking to make sure you don't have any extraneous roots. So if we multiply both sides by x plus 1 and x minus 1, you get this. Again, things cancel out nicely. Your goal, obviously, again, is to get rid of the denominators. The x plus 1's cancel out there, and both cancel out on the right side. If you put this all together, you get x plus 1 times 2x plus 3 minus x minus 1 times 2x minus 3, all equal to 10. Now again, you have to FOIL it and then combine like terms. So you get that. The x squares drop out nicely, as do the 3's. So you're left with 10x equals 10, and x is equal to 1. Now remember, you have to make sure that 1 is not an extraneous root. So you plug it into the original equation to make sure it doesn't cause the denominator to be 0. Unfortunately, it does. It causes this to be 0 and this to be 0. Since that is our only root, there is therefore no solution to this problem. That's it for section 5.9. If you're still confused, please call me, or not call me, but please ask me on email or Facebook, and spend some time in tutoring after school on Tuesdays and Thursday. I'm more than willing to help you. The Chapter 5 test is probably going to be on Thursday, so you'll have a couple chances to ask me questions. We'll do a review beginning on Tuesday. If you have any other questions, let me know on Facebook or via email.